All right, guys. Rest of the students may join in a couple of minutes. We are going to continue with the class. Okay. All right. So this is all about data availability that you have for your petrophysical interpretation. Uh, so now it is very clear for all of you guys that if I'm talking about the well log data availability, then it means you need to check that how many well logs or suits you have in your well, or if you are interested in your any specific reservoir or in any specific formation that have certain depth interval, then you need to know how many different logs executed against this interval, and this information you will get from your end of well report or the completion report. After that, definitely you will got this data in the hard form or in the digital form. So if you got in the digital form, then it means you have your data is in LAS, list, daylist, or in the ASCII format, or whatever the format that your software is supporting. You need to import this data into your software to start the interpretation. Before starting the interpretation, it is very important to know about the well bore environment that may affect your logs. So this diagram is basically showing the example of the well bore environment. So let's assume that this is your well bore, and when you are drilling this interval with the help of bit, the mud coming inside from the drill pipes and going out from the bit and picking the sample and moving into the upward directions from the annulus. Annulus mean the whole size or the hole apart from the drill bit or the drill string. अगर आप वेल बोर में से ड्रिल पाइप्स को निकाल दें तो जो भी आपका ये वेल बोर है इट इज नोन एज द एनुलस. Obviously, in this annulus you have the drilling mud, and this mud having a lot of functions. Out of these a lot of functions, the first one is to pick the sample and take at the surface, and the second major use of this mud is to insert the pressure on the wall, on the wellbore walls. Why? And the reason is different formations or majority of the formations having the fluid in the pores. This fluid may be fresh water, maybe saline water, or maybe hydrocarbons. When you start drilling, this fluid coming out from the formations into the wellbore. So while I'm drilling, I don't want this fluid inside the well annulus or into the wellbore. So I need to stop this fluid movement from the formation towards the annulus. So how I can control it? I have just only a one medium. I can control it with the help of mud filtrates. So you have the mud filtrates that inserting some pressure on the walls of your well. If I'm talking about here, your mud filtrates inserting pressure in this direction towards the wall of the formation, and your formation fluids coming into the annulus with the known formation pressure. So how we can keep this formation fluid inside the formation just increasing the pressure little above the formation fluid have. Mean if formation fluid having 250 psi, then I need to maintain the pressure for the drilling mud at the same depth point little above the 250 psi. It would be 251 or 252 or 255. But and also I cannot increase at the maximum my drilling mud filtrates are like 300 or 350 psi. And the reason is if you have if formation fluid pressure greater than the drilling mud filtrates, then what happening? The formation fluid comes into the wellbore. It is danger for us because when the fluid coming into the wellbore, that cause to reduce the viscosity of the drilling muds, and due to this we cannot pull samples towards the surface. And what if I have the drilling mud pressure greater than the formation fluid pressure? Then in this way, if I am in the porous and the permeable formation, my drilling muds filtrates trying to invade inside the formation. When they're going or starting to invade, then what's going with me? Nearby the wellbore was all of the fluids replaced with the drilling mud filtrates, and we observed the loss in drilling muds that also caused to uh, change or reduce the viscosity, and then we are unable to pick our samples at the surface. So therefore, we need to just maintain the pressure little above the formation fluid pressure. In this way, formation fluid cannot enter into the wellbore, and also drilling mud cannot penetrate or invade into the formation. But it is the game of maintaining the pressure. We have the drilling mud's pressure just a little bit greater than the mud formation fluid pressure. But therefore, the invasion is take place. You cannot control it. Little bit invasion is take place at any formation that is porous and permeable. Therefore, we can divide our formations into three zones. The first zone is the flushed zone. Flushed zone is the zone where my drilling mud filtrates completely replaced the formation fluid. यानी कि उनका प्रेशर ज्यादा था तो उन्होंने उस इंटरवल में कंप्लीटली रिप्लेस कर दिया बैकवर्ड की तरफ. तो वहां पे अब अगर मुझे कोई फ्लूइड मिलेगा, इट इज द ड्रिलिंग मड फिल्ट्रेट्स, not the formation fluid. This zone is known as the flush zone. And next to the flush zone is the transition zone, where you can observe the drilling mud filtrates and also the formation fluid. Basically, you can get the mixture over there. And in the last, you got the uninvaded zone. That is the zone where you only got the formation fluid. So this invasion is totally dependent on the type of mud filtrates you have, and dependent how much you have greater the pressure with respect to the formation fluid, and how much your formation is porous and permeable.
Sir, I have a question.
Yeah.
Sir, I want to ask that you said that the formation fluid can enter into the borehole through the walls, and so I have a question that the drill pipe walls, which is maybe of steel or somewhat else, wouldn't prevent it. to get in? How the formation fluid come into the borehole?
All right, let's drawing the sketch. All right, I am assuming this is your well bore and this is your formation. All right, in between this you have your drill pipes, and at the end you have bit that continuously drilling. You are drilling mud coming from inside for these drilling mud pipes or drilling pipes, and will be out from the nozzles of this bit, picking sample and moving out through these empty spaces towards the surface. All right, it is clear. Now, this is the intersection of this formation with this fluid. This formation, obviously, if this formation have the fluid with certain specific pressure, then it tries to enter into this well bore, because the fluid always trying to move from higher pressure to into the lower pressure zone. When you start drilling, then this empty space behave like a low pressure zone, and fluid start moving from high pressure towards the low pressure. How I can control this movement? Because I don't want this fluid inside the annulus or inside my well bore. I just only have the one way, because this drilling fluid is also inserting some pressure on the wall of the well bore. If I can maintain this pressure, just keeping the pressure little above the pressure that formation fluid have, then I can control it. This fluid cannot be entered into the annulus. And the reason is, if this fluid is entering into the annulus, then what happening? The first thing is the viscosity or the density of the drilling fluid going to decrease it, and uh, that cause to drop all the samples at the bottom, because using this viscosity and density, we pick the sample from the bottom and moving towards the surface due to this density contrast.
Yes, sir. Thank you, sir.
Yeah.
Thank you very much. Yes.
So in the wellbore, basically you have three different zones. The first one is the flush zone, where the drilling fluid completely replaced with the formation fluid. Second is the transition zone, where you can get the mixture of the uh, drilling fluid and the formation fluid. And last one is the uninvaded zone, where you got only the formation fluid. All right. So now if I want to calculate the true resistivity of the rock, then I need to calculate the resistivity of the uninvaded zone, correct? Because in the transition zone and in the flush zone, we have the formation fluid is altered with the drilling mud filtrates. When this drilling fluid trying to invade inside the formations, definitely every drilling mud filtrates having two segments. The first one is the solid particles, second one is the liquid. The liquid will be water, water may be fresh or saline or hydrocarbons. And the solid particles may be calcium, maybe salts, maybe barite. That depends on the condition, how you can maintain your density of your drilling filtrates, mud filtrates. When this drilling mud filtrates starting or invading towards the formation, the liquid part move into the formation, and the solid part make the mud cake against this formation. The purpose of this mud cake to stop these spores or block these spores that cause to invade or move formation fluid towards the annulus because I don't want to move or invade my drilling fluid inside the formation, or I don't want to uh, formation fluid inside the annulus. Therefore, this mud cake is basically block all the pores. So the question is, where the invasion take place quickly, either in the porous formation or either in the permeable formation. And the second question is depth of invasion, where we get the maximum depth of invasion, in the permeable formation or in the porous formation. Can anyone elaborate? कोई बता सकता है मुझे?
सर परमिएबल फॉर्मेशन में दोनों केसेस में हाई होगी सर, डिवीजन भी हाई होगी और सेकंड जो है इसका
फर्स्ट वन है इसके क्विक कहां पर होगी, सेकंड
Yes,
क्वेश्चन है
sir.
इसके डीपेस्ट कहां पर होगी.
सर परमिबिलिटी होगी तो इन्वेजन होगी,
हम्म.
वो दोनों केस में परमिबिलिटी ही है मेन.
सर दोनों चीजें चाहिए, पोरस भी और परमेबिलिटी दोनों चीजें चाहिए उसकी ज्यादा इन्वेजन के लिए.
I am giving you the two options. Number one formation having low porosity, high permeability, and the second formation having the low permeability and high porosity. अब मुझे बताएं इन दोनों में से किसमें ज्यादा डेप्थ ऑफ इन्वेजन सबसे ज्यादा किसमें होगी और क्विक किसमें होगी.
सर परमिएबल में डीपेस्ट इन्वेजन होगी और क्विकेस्ट इन्वेजन जो है वो हाईली पोरस में होगी.
सर आई थिंक परमेएबल में, दोनों केसेस में परमेएबल में ज्यादा होगी.
चलें अब आप मुझे ये भी बताएं क्यों ज्यादा होगी.
सर इसका जवाब सर ये कि परमिएबल में सर उसकी कम इन्वेजन होगी ड्यू टू सर फॉर्मेशन ऑफ मड केक, और जो इम्परमिएबल होगी सर उसमें जो है वो इन्वेजन ज़्यादा होगी क्योंकि उसमें जो है वो मड केक जो है वो इतनी जल्दी नहीं बनता.
राइट भाई, अगर परमेबल फॉर्मेशन है ना, इफ द फॉर्मेशन इज परमेबल देन व्हाट हैपनिंग, द इन्वेजन इज क्विक. Very quickly my drilling mud filtrates going inside the formation, but what happening, these solid particles quickly made the mud cake. बहुत जल्दी वो मड केक बना लेंगे. अब मड केक बन गया तो फ्लूइड की मूवमेंट स्टॉप हो गई. क्विक तो हो गई परमेबल के अंदर, लेकिन मूवमेंट स्टॉप हो गई. टाइम ही नहीं मिला उसको इन्वेट करने का, बहुत थोड़ा सा टाइम मिला था. क्विक हुई 1 मीटर के लिए और फौरन ब्लॉक हो गए पोर्स. दैट इज इट, खत्म. What happening if the formation is porous and very less permeable? सॉलिड पार्टिकल्स वो मूव ही नहीं कर पा रहे इनसाइड द फॉर्मेशन. जब वो मूव ही नहीं कर पा रहे तो वो मडकेक कैसे बनाएंगे? वो मडकेक नहीं बनाएंगे. जब वो मडकेक नहीं बनाएंगे, इट मींस योर लिक्विड पार्ट हैविंग इनफ टाइम टू स्लोली इन्वेड टुवर्ड्स द फॉर्मेशन. अब इसको टाइम ज्यादा मिल गया, तो अब क्या होगा कि इन्वेजन स्लो होगी लेकिन डीप होगी. किसमें? जहां पर पोरोसिटी ज्यादा है, परमेबिलिटी कम है. And where you got the higher permeability and low porosity, then it means the invasion is quick, but the depth of invasion is very low as compared to the other formation that have the low permeability and the higher porosity. Correct?
Right, sir.
So this is about something about the wellbore environment. If anyone have any question till that, then please.
Sir, only one question left, that if the material of the stratigraphy or the zones is so soft that it just collapses into the borehole, then what we can do?
This is the problem of the drilling. This is not the problem of the logging, right? If you are trying to drill the soft formation and you feel that we have the chances to collapse the formation, then it means you need to take some remedies, and trying to put the casing just below this soft formation to stop this or to collapse this valve.
Sir, if you found breakout in the borehole, then it will affect on the reading of neutron logs or density positive log.
Sorry, please repeat again.
सर अगर ब्रेकआउट बोरहोल में मिल जाए आपको,
जी
ठीक
जी
है, तो उसमें आपको न्यूट्रॉन पॉजिटिव और डेंसिटी पॉजिटिव पे रीडिंग पे कोई फर्क आता है सर? या
ब्रेकआउट
सोनिक की?
अब दैट डिपेंड्स ना कि ब्रेकआउट की टाइप क्या है.
सर ब्रेकआउट आप उसकी टाइप का क्या कर सकते हो?
You need to describe the dimensions of the forces, डायरेक्शन किस तरफ है इसकी. लेकिन अगर आपका होल बिल्कुल एग्जैक्ट सिमिलर टू ड्रिल बिट है कि आपने 8.5 से ड्रिल किया है और बिल्कुल 8.5 के ऊपर ही है, देयर इज नो चेंज इन, तो वही तो बेस्ट एनवायरनमेंट हुआ ना आपके लिए लॉगिंग करने का. बट इन फैक्ट यू डोंट हैव. तो ये तो बात की बातें अभी हम के ब्रेकआउट होंगे या ऑन गेज सिचुएशन होगी तो हम लॉगिंग को किस तरह देखेंगे. ये तो लॉगिंग के रिजल्ट जब हम इंटरप्रेट करेंगे तब इन चीज़ों को डिस्कस करेंगे. एंड डेफिनेटली
सर
all of the scenarios having some impacts on the logs.
सर
जी
सर आपने मतलब सर इन्वेजन सम हमारे साथ सर उधर कम होगी सर जब फॉर्मेशन की सर पोरोसिटी लो और हाईली परमेएबल हो सर, तब सब लो होगी और डीप होगी.
जब आपकी फॉर्मेशन की पोरोसिटी ज़्यादा है, परमेबिलिटी कम है, तो इन्वेजन स्लो होगी और डीप होगी. अगर आपकी फॉर्मेशन की पोरोसिटी कम है और परमेबिलिटी ज़्यादा है तो क्विक होगी लेकिन कम होगी. ठीक है,
क्योंकि सर मटके की वजह से फॉर्मेशन
मटके
से
की
सॉरी
वजह
बट ठीक है.
एंड द रीजन इज कि परमेबल के अगेंस्ट मटके जो होता है वो क्विकली डेवलप हो जाता है. Any other question? All right, so this is all about today's session, and at the end of this session, according to our workflow, we covered our first point, that is related to the data availability, and now I think all of you guys having some basic concept about the well log data availability and about the well logs and little bit about the digital log formats and what is the borehole environment that you need to know while you are going to interpret your wildland logs. And from the next week, we are moving towards our second point, that is related to the data quality check or applying the corrections or correcting the data before starting the interpretation. So we will be going to discuss how many different methods we have and how we can correct our data. All right, and then we will moving towards the logs.
Okay sir.
Okay, sir.
Okay sir.
Thank you guys, and we will meet you again in the next week. Bye bye.
Thank you.
Okay sir, thank you.
I will
Okay, sir. Thank you.
upload all of the videos and then we'll intimate you in the WhatsApp group. Okay.
Okay sir, thank you.
Okay, sir. Thank you.
Thank you, sir.